Okay, let's have a look at the first one here. Okay, do you have a spare pen, and I could borrow? This one might work, huh? Cool, thanks. Okay, the first one here. The refractive index of water is 1.33. How fast will a radio wave travel underwater? So you have the formula N equals C over V. So in this case it will be 3 times 10 to, that means that 3 times 10 to the 8 over V equals 1.33. So V is 1. No, what have I done? I've done something wrong here, haven't I? I'm too tired. Is the formula C over V?
Yeah.
Okay. 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 Oh yeah, no, I haven't done anything wrong. Sorry. I'm just still asleep. 3 times 10 to the 8 over 1.33. So what's that?
2.5 times 10 to 8.
2.25
Yeah.
times 10 to the 8. Alright, that's okay, isn't it? To start with. Can I scroll down, guys? Did you both get that? Siba, yeah? Okay, the next one now. The refractive index of water is 1.33. A beam of light enters the water at 45 degrees. What does it make of the normal after it refracts? I should say. It refracts. Okay, so you have your air, you have your water, and there's the normal. And the light comes in at 45 degrees, then it refracts, and this here is 45, and this here is our theta, and we want the theta, okay? So we have, Snell said, sine 45 over sine theta equals n2 over n1. Yeah? Did you get that? It's okay if they're both switched. What did you have?
I have the same, but on the other side is.
Ah, that's a problem. So theta is then going to be sine inverse 1 over root 2 over 1.33. If you were to type that in, you would get the answer then. What's that? So
$32.1.
32.1? Okay. Yeah?
Yeah.
Okay. Part 3. What's the critical angle for diamond? It's sine inverse 1 over 2.42. And what's that? 20.4. Okay. Okay. Now, what is the meaning of that angle? So, imagine you have some light inside your diamond, and you want the light to come out. Here is the angle. No, sorry. I didn't do it the right way. That's the normal. And here's the critical angle. That's about 24.4 degrees. If if the light is 24 or less, then it refracts back in. If it's more than 24, then it can come out. Yeah? So, let's see. 24 is not as big. It's not as big or as small as I thought. I think 24. Yeah. So I think having such a small angle here means, I'm not sure how, but I'll have to check it up now. It doesn't matter. I can't remember exactly the reason why, but the reason diamonds sparkle so much is because this angle is so small. I think what it means is that it's very easy for the light to come out. Because the angle is quite small, it means most of the time the angle will be big enough so it'll come out. This thing might make it sparkle. But I'm not sure though, I'll have to check it. But I'll just write, it's what causes the sparkle effect. Ciao, there you are. Okay. Continue. Yeah. Kaboom. Okay, now on to the really hard question. Question 4. I wonder if you were able to get it. No. Do you think you got much of it? Did you get some of it? No? You drew the picture? Okay. So, here's what you have. You have your table. And you have your equilateral prism. I drew a picture there for you. And you have some green light. And it comes along parallel here. Okay? Then what happens? It, of course, refracts. Well, let me try and get the angle roughly right. So that's the normal. So that's the first angle. So it becomes smaller. So I think it will look like it'll go down here. You get a smaller angle here. And then here's the other normal. Ugh. Then it'll come out again. Let me draw in, that's that angle there. I need to make this bigger. I can't see what I'm doing. Right, that's better. Okay. Let's take this step by step. My first job is I want to figure out this angle here. Okay? Now, there's some angles we do know. Do we know these angles? Yeah, what are they? Say again? Not 45? For equilateral triangle?
That would be 60 degrees.
60. 60, yeah. Okay, so that's 60. which means, can you see here, how much is this? How much? 60. So, how much is this? No. Try again. This is 60. This is 90. So how much is this? 30. So that's 30. Yeah? Is that okay, Chow? Yeah? So let's calculate. Sine 30 over sine theta equals 1.45 over 1. So theta is sine inverse sine 30 over 1.45.
$20.2.
20.2 degrees. Okay. So, let's see, that means 20.2 should be like, ugh, my blooming triangle. Get rid of this thing. Okay. So this here is 20.2. Then it hits here, and there's another normal. Oh my goodness. I really hate drawing this. I know this doesn't look nice, but whatever. Okay, so let's see. Let's try and zoom in here, and we have to figure out this angle. Now I know it looks like it, but we don't actually know that this here is 90. I mean, if this was 90, that would be nice, because then we'd have this angle here, but we don't. So you need to figure out this angle. So let us try and do that. My goodness. Okay. We can know this angle, can't we? It's 90 minus 20.2. So what's that, 60.8?
60.
Is it?
Sorry, 19 minus.
Yeah.
68.8.
Oh, sorry, it's 60, what is it?
69.8.
68, 69, 69.8. Yeah. Now, we know that this guy up here is 60. So we know that this one here is 180 minus 60 minus 69.8 then. So what's that, please? So that's 50.2. If this whole thing is supposed to be 90, then it means the angle that we want is 90 minus 50.2. So it's at 39.8 then. So by repeating the process, sine 39.8 over sine theta equals 1 over 1.45. You can get theta is sine inverse sine 39.8 over 1.45.
$26.2.
26.2. Thank you. So that there is 26.2. Now, the last thing we need to do is figure out this angle, because that's my question. What's this angle here? So let's try and figure that out. Whew. Let's see. Could I know this angle? Yes. You see this angle here? Because the total here is 90, isn't it? So in here, that's 90 minus 26.2. So what is that, please, Siva, if you don't mind? 90 minus 63.8. Now we actually also know this angle here, don't we? Because how much is this angle? That's 60. Yeah? So how much is this one? Oh, something's gone wrong here. 120 plus 63 is more than 180. So some angle's not right here. Oh, maybe it doesn't hit the table. Did I draw something? I get something off here. That's 30. That's 20.2. Do you know what? I made this question too hard. Oh. Goes up. That's 30. That's 20. Maybe the light doesn't hit the table. Maybe it goes like this. Maybe I have it wrong, my picture. So what I'll do, I'll change the question. So my question now is, at what angle does it leave the prism? So we'll make that 26.2 then. So I'll make the change. At what angle does the light exit the prism? And that's 26.2. Okay. I think my picture's wrong. I think what happens is like this. It must go up at the end. Although, I did this question the last 2 years and this didn't happen. Well, I'm trusting that you got the right angles here too. I can trust that you got the right angles. Anyways, no big deal. Can I scroll down to the last one here? Yeah. 3 panes of glass are stacked as shown below. The refractive indices are 1.3, 1.4 and 1.3. And light travels through the first pane at 30, it then enters the second and then enters the third. At what angle does it travel through the third pane at? So, okay, you have 3 pieces of glass. 1, 2, 3. And the refractive index is 1.3, 1.4, 1.3. And then here's the normal. So I think I said the light comes in, did I say 30 at the beginning? Is that right? Is that 30? Yeah, okay. So let us calculate, and this refractive index, because it's air, is 1, and this one here is 1 as well. So this is air, glass, 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 air. Yeah? Okay. let's get the angle here. So, using our formula, it's sine 30 over sine theta equals 1 over 1.3. So then that means theta is sine inverse sine 30 over 1.3. So what's that here? $22.6. Okay. So this angle here is 22.6. So if I draw another normal, this angle here, that's the same, isn't it? Yeah, it's also 22.6. This angle here is the same as this one here. My picture's quite small, I'm sorry. So we have to repeat the process again. This time it's sine 22.6 over sine theta equals 1.3 over 1.4. So that means this time theta is sine inverse 1.4 sine 22.6 over 1.3. So what do we get there? Twenty 24.4 degrees. Okay, so I think you see what's happening here. If that's 24.4, then if I draw another normal here, this angle here is also 24.4. So now the next one's going to be sine 24.4 over sine theta. That's equal to, oh, rats. Did I get this one wrong? I'm sorry. I made the Seba mistake of having it upside down. This one here should have been, this one is, let me give these letters so I don't get confused. Alpha, beta, gamma, delta, epsilon. So the first one was alpha to beta. Then this one here is beta to gamma. Ah, well done. 1.4 over 1.3. So that means that's 1.3 over 1.4. Well, it's good that I saw it now and not later. Okay, so what's that? $20.9. Okay, so that's 20.9. Thank you. So that means that's 20.9. So the next one we're on to now is gamma to delta. So that should be sine 20.9 over sine theta is equal to 1.3 over 1.4. So that means theta is sine inverse sine 1.4 sine 20.9 over 1.3. Okay. That was my question. At what At what angle does it travel through the third pane at? So that's the last piece of glass. So that's 22.6. Now, the reason I did this question was because there's kind of something interesting here. You saw the 22.6 somewhere else, didn't you? Yeah, it was the angle here in the first piece of glass. That's the same one as the angle in the third piece of glass. Now that always happens if you have this, if the first piece and the last piece are the same. So, in fact, it doesn't actually matter what this piece is. Could be any number. The angle you get here and here will be the same. This one might be different, of course, if this is different, but as long as these two are the same, then it means this angle and this angle is the same. And that was what I wanted you to figure out here. Okay. Right, now that was hard. That was a hard lesson, that one. That's a hard one. Okay, let's look at the next one. Yeah. Okay, good.